Hello and welcome to another tutorial. We are going to continue our discussion on GraalVM native image and how to compile our Java application to native binary. And I mentioned that the first thing that you need to learn or be really familiar with is how we actually launch a Java application using the JDK or the tools that come. And we said that JDK has development tools. These are usually the compilers, the debugging tool like JDB, etc. Or for example, Java Flight Recorder, JFR, which monitors the performance of your application inside the JVM. And we said that you launch your Java application by using the Java command line tool, right? It's an executable binary that comes with a JDK, and this is the runtime. And in the past, it used to be called JRE or Java Runtime Environment. And now they decided to only provide one JDK, which also includes the JRE, right? In the past, you could just download the Java or JRE as a smaller file, but now it's just one JDK, and it has all the development tool and the runtime tools, right? And we said that eventually what we want to learn is that how the JVM handles your Java application. JVM understands only the class files. Each class declaration in your source file will be compiled to a separate class file. Whenever JVM at runtime encounters an object of some type, it tries to find the class file that corresponds to that. The first time that this happens, the JVM loads the class file into memory so that it understands the properties or the attributes of that type, right? Every type in Java is a class or object with two exceptions. One is the primitive types like integer, float, double. These are built-in types. JVM doesn't need to look for a class file for them. And the other one is the built-in arrays like int array, double array, or any object array. Those arrays or primitive arrays in Java, arrays are built-in types inside the JVM, which means JVM doesn't need to search for a class file to understand what an array type is, right? So primitives and array types, these are built-in types. Other types, like for example an object or whatever class you define, these get compiled to a separate class file, and JVM loads the class file into memory to understand what the properties of this type are, what are the attributes, what are the static methods, what are the non-static methods, etc., right? And loading the class files only happens once during the lifetime of your application. The very first time JVM looks at the type and sees that it doesn't understand it, it tries to search for this a class file that is associated with that type. And that's where the importance of the class path comes into play. We said that when you interact with the terminal, we said that there is a environment variable called path, right? This is what your operating system and the terminal understands. Similarly, when you launch your Java application, you can specify class path, hyphen class path, or I usually prefer the shorter version -cp. And this tells the JVM all the directories that it can look into to find a particular class file. So that's how you do it, and it's exactly the same as the behavior of the class path for the JVM is very similar to the behavior of the path environment variable for the terminal or operating system, right? So if I say Java, what happens behind the scenes, as I mentioned in the previous lecture, is that the operating system starts to search in all the directories that are specified in the path and tries to look for a executable binary that has this name. At the very first directory that has an application with this name, it just assumes that that's the case, and it uses that application, right? Same with the Java class files, and we will look at it. And in general, if you want to launch your Java application with the terminal, from the terminal, now obviously these days everybody uses an IDE, and I will show you how an IDE like Eclipse handles this. But every IDE has a build system, which means the way they organize the classes and then they configure the class path, because you can launch your Java application from within your IDE. And IDE behind the scenes basically configures this parameter -cp. Basically it tells the JVM where are the directories that the class files are, right? But then even for your terminal, you can define a global environment variable called I believe class path, right? This is the JVM understand. So by default, if you define a global environment variable called ClassPath, then the JVM actually also looks for this in the environment variables of the operating system. Same with Python. If you're familiar with Python, you can define a global environment variable for your terminal, for your operating system, called Python path, right? And then when you launch Python application, it also searches if it finds a global environment variable with this name. It also adds all the directories that this has into the Python path, right? So JVM looks for a variable called ClassPath. You don't need to define this. You can, but if you define this, then you don't need to really pass this -cp at the launch time. All right. So the idea here is that when you launch your Java application with the JVM, what happens is that obviously your application depends on the Java API, which means the JDK classes and libraries that come by default, right, with the JDK. We know that Java Lang, all the classes, all the types in the Java Lang package, they're always implicitly imported. You don't even need to import them, which means they are very essential part of every Java application. And then JVM loads all these APIs into memory before even loading the class files that are associated with your application, before even starting the main method of your application. And then JVM sits between your Java application and the operating system, right? So every line of code in your application gets executed by the JVM. Basically, JVM interprets that for your operating system, and operating system is the thing that sits between a user, an application, and the hardware, right? The only way to talk to the hardware, utilize the hardware, is through the operating system. So the application talks to the JVM, right? Or it gets executed on top of JVM. JVM talks to the operating system, and then operating system handles all the hardware events, right? And we saw that this communication between your Java application and the JVM is in the form of class files. So you define classes, define types. Those types get compiled to class files, and then when you run your Java application, JVM loads the class files into memory and then understands the types that you're using, right? Now, what we want to do, we want to transition from this behavior to a native image. Native image means we launch your Java, we write our source files, right? Our Java application. And then there is a compiler, which we call it native image compiler. And then what happens here is that instead of compiling all the JDK classes, classes and our Java source code to class files, the compiler does a static compilation, which means it compiles all of these into a native executable binary, right? And then when you run that executable binary, it means you're launching your Java application. There is no JVM in between, right? So operating system directly loads that into the memory. So basically the execution of your application now is in the hands of the operating system, right? The standard procedure is on the left side, where the execution of your Java application is in the hands of JVM. And then JVM talks to the operating system. Obviously, you can see that because the JVM is an extra step here. The execution is a little bit slower than if you directly execute your application via the operating system. And that's why people always say that C++ applications are obviously faster, because the execution is really in the hands of the operating system itself, right? So let's head to Eclipse. I'm going to show you how to write a Java application, a very simple one, the Hello World application, how to manually compile it through the terminal, how to run it with the JVM, with the Java tool, and then we're going to discuss complexities like packages, and then what's the importance of the class path. All right. But again, all these, I'm going to show them how they work in the terminal first, and then we look at how the IDE handles them. So I've created a project in my Eclipse IDE called Java Native Image, right? And I've configured this project to use Java 17, but I'm not going to use this Java project that Eclipse manages. I'm going to create an empty folder like test, and then I'm going to open a terminal here. All right. So what I'm going to do, I'm going to create a basically empty Java file. So I'm going to say, for example, cat or maybe echo hello to a file, let's say hello world.java, right? If I do a ls, you see there is a hello world.java, and I'm going to open it with the Eclipse IDE, right? Eclipse text editor, and I'm going to type my class, right? So let's call it a public class. So public class hello world, right? In Java, everything is inside the scope of a class, right? And when the Java compiler compiles this class definition, this gets compiled into a binary file which has an extension .class, right? So it gets compiled to a binary file which ends with the name is going to be hello world class. And when you launch your Java application, the JVM loads this class into memory. And in order to execute, so the entry point to your Java application, if you are not developing a library, right? If you're developing a Java application, which means you want to execute your application, is the main method. So public, static, it has to be public so that JVM can always access it. It has to be static so that the JVM doesn't need to instantiate this class. It doesn't need to create an object. Main doesn't return anything. In C++, you know that main actually can return 0, an integer, but it's not necessary. The default, nowadays the default behavior is that if the main executes successfully, it returns 0. But JVM doesn't care. That's why they decided to declare this as void. You don't need to return 0 or whatever. Public static void main. And we said that there is a concept of command line arguments, and that's the string array. Remember, when you launch your application in the terminal is a text-based interface. Everything in the terminal is text, right? You run your application, the application can get some input as text, and eventually it returns something back as text. Even if your application returns a number, does some calculation, the terminal, in order to display it on the terminal, it has to be in the format of text, right? Why do we have string arrays? Because when you launch your Java application, let's say eventually we will say hello world, right? You tell the operating system to launch the JVM, the Java tool, use this class file which has a main method, and then after that whatever comes, arg1 space arg2, etc., right? So you can have a comma separated list of strings, and all these are going to be translated into this string array. So you have to add spaces between them. And then we're going to say system.out.println. This is from the JDK. That's why our application always depends on the JDK. Hello world, right? Hello world from Java application. From Java application. And some exclamation marks. So we save this text file is ready right now to the operating system. This is just a text file, right? It doesn't have any meaning. So let's go back to our terminal, and what we want to do, we want to convert this text file, which is our source file, into a class file so that JVM can load it into memory and execute our application. So the way we do it, we have to use the compiler. So, and again, what I always like to do first to see which version of Java I'm using and where is this Java executable come from. Remember, I said that the which command tells searches in the path environment variable to see where the operating system can locate this executable. Now I'm using the Oracle JDK 17. So my Java is Java hotspot. And same with the Java C or Java compiler. It comes from JDK 17, Java C -- version. And as you can see, I'm using the Java C17, right? So what we're going to do is compile this source file, Java C, and then you give it the name of the class, hello world.java. It takes a little bit of time. If we do a list again, you see now we have a hello world.class. So if I refresh here, the hello world.class comes in, and Eclipse, when I drag it into the editor, I've configured the Eclipse to decompile the class. But you can also open it with the class file editor. So this translates the binary contents of this class file. Remember, the contents of this class file is binary. It's not a text. But then you can basically look at the content, basically the contents of this using the Eclipse class file viewer. So the binary is translated into a public hello world. This is the constructor. We know that if we don't provide any constructor, the compiler will add a default no argument constructor, which is public. That's there. And the job, all it does is it calls the superclass constructor. We know that the object class, Java lang object, is the superclass of every type. And the superclass of a type has to be initialized in the constructor of the subtype. That's why we call the constructor of the superclass. And then we have one method, main, which is public static void. It gets a static field from Java lang system, which is out of type print stream, and then loads a constant string, and then invokes a non-static or virtual method from this print stream class, which is out, right? This out is of type print stream, and then this method is overloaded. The print line takes this particular method, it takes a string and returns void, and then eventually we return from our main method, and the Java application terminates, right, successfully. That's how this works. So behind the scenes, the very first thing that you see that happens is that Java C adds a default constructor. Every class, every type has to have a constructor. If you don't provide one, a default constructor will be provided by the Java compiler. All right. So back here, now that we successfully compiled our Java application, we want to run it, right? So we use Java C to compile the application, and now we want to run it. We use the JVM or Java command, right? And then we don't give it the source file. We don't use the Java file. We use the class file, because JVM or the Java tool, Java exec, only understands the class file. And you give it the class that has the main method, right? So you may have multiple classes that have main methods, and you have to tell the JVM which class is the entry point to your Java application. And when you do that, the JVM looks at that class file and see if there is a main method, public static void main method inside that, and it tries to execute it. So hello world. And when you do that, you don't type the dot class. You don't do that. You only write the name. So if I launch this, it successfully executes, and you see the terminal. Again, you launch your applications through the terminal, right? Terminal is the window between you and the operating system, and every application has to be run through the terminal. Every application, therefore, when you run it, it has a working directory. So right now, this test directory is our working directory. And then there are ways in your Java source code to examine the working directory. When you launch your application in the in Eclipse, every IDE sets the working directories differently, right? In your Eclipse IDE, you can just say run as, right? And then this doesn't work because I didn't compile this with Eclipse. Eclipse when you say run as, it tries to basically create a run configuration. Eclipse has its own compiler, and it organizes the class files into a separate directory called bin. But here we didn't do that. We put the class file exactly in the basically source file, in the directory that had the source file, right? So Eclipse doesn't understand it. So remember, IDs configure the class path, and then differently. They have different folder directory hierarchy as to where they put the class files, the binary files, right? And then eventually, when you launch your application, the IDE tells the JVM or the Java tool which class to use as the main method that has the main method, and then how the class path is configured, which directories to look into when JVM tries to search for a class file. Now again, our application is giving us feedback in the format of text, and that's the only thing that we do. For example, if we do a system out print line 5, right? Remember, this 5 is a primitive integer in your Java. When the Java compiler sees this becomes a primitive integer, right? This is not a string type. But then in terminal, when you tell, hey, put out 5 to the terminal, this out means output to the system, which is output to the terminal. This 5 gets translated into the 5 in the format of a string, like basically 5. Because terminal doesn't understand primitive types, it just understands strings, right? Now, obviously, if I change something in the source code and launch my application, the changes are not reflected because I have to recompile the source file. So you have to first save it, right? And then go back here and say java c hello world.java. You compile it, the binary file or the class file gets updated. Now if I type java hello world, and see the 5 is there. But again, terminal, when it gives you feedback, it's always in the format of text, which means there is no really difference when you run your application between these 5 as an integer or 5 as a string. The feedback that your application gives is basically the same, right? I want you to understand this very carefully. All right, so that's the first thing, how you handle your Java applications, how to compile. This is the simplest case, right? And then there are a few things that we want to explore. The one is, what if your application becomes more complicated, right? And one thing that I want to mention, that in this case, I'm not giving any parameter for -cp, the class path. But when you don't specify this explicitly, JVM, when you launch your Java application, JVM searches in 2 locations. One is the current working directory. So you know that I launched my Java application from within the test, right? Now what I could do, I could actually go a folder up, go into this Java native image. Now I'm in this directory, which is outside, one level up, right? And now if I go back, okay, actually we want to, let's close this terminal and then go back to the other one. If I say Java hello world, this doesn't work because JVM says that you tell me to look for a class file with this name, hello world, but I could not find or load the main class hello world, Java lang class not found exception hello world. So basically it's telling me I couldn't find a file, a binary file called hello world.class. Because when I launch this application, it tries to search for a class file in this directory, right? So the correct thing to do is tell it to go, give it a relative path from current directory, go into the test, and then hello world, and you don't add the dot class, right? And again, this doesn't work. Why? Because so the reason this doesn't work is that you cannot specify a path. So Java tool has a strict rule that you cannot give it a executable in the format of a path. Java doesn't understand it. In fact, in your operating system, if you have an executable binary, you can give it a path. We've already seen this, right? For example, instead of typing Java, you can say /library Java virtual machine JDK17 bin Java, right? But JVM doesn't do that. It's not correct for, you have to, instead of giving a path that leads to your class file, you have to give it the fully qualified name of the class, which includes the Java packages and Java hierarchy. I assume you're already familiar with the fully qualified name. If not, I will discuss this in future lectures. So when you launch your Java application, you cannot give it a path to the class file that has the main method. That's not correct. That doesn't work for your Java application when you use JVM, right? But for operating system and native executable binaries, that works. You can give it a relative path, absolute path to an executable binary, and the operating system understands how to execute it. But that doesn't work for Java application, right? You have to specify something called the fully qualified name. Fully qualified name only understands the packages and basically only understands the packages and the class name, right? So right now this Java class, we didn't put it in any package. So the fully qualified name is actually the name of the class. Now you can see look at the fully qualified name. If you open this with a class file viewer, you see there is no package. If you put this type or the class file into a package, then the name of the class or the type has dot package, like package1 dot hello world. But right now the name of this type is exactly the name of the class that we define. All right, if you don't know what these things are, packages, fully qualified name, I have a full course on becoming the master of Java. I highly recommend you to go sign up for it and then learn these concepts. These are very important. So this doesn't work. We cannot tell it, hey, from this Java native image, go inside the test directory and then execute a binary class that has hello world. This doesn't work because Java JVM doesn't understand the operating system path, right? It doesn't understand the file path. It understands the Java path, which is different from the file path. Java path is with respect to the class path or directories that are specified in the class file. So what we need to do, we need to, instead of telling it go into the test directory and execute the hello world, which doesn't work, we have to specify the directory, the test directory, as part of the class path. So .test, right? So if we launch this, now our application works, which means so we have a class that has a main method. The name of that class, the fully qualified name, is just the name of the class because it doesn't belong to any package. And then we tell JVM to search for this type that has a main method inside this directory. Now we could tell it to basically we could have multiple directories and you have to separate them with colon. So for example, one thing that we always want to do is also append dot to it. Dot means the current directory and the directory in the test directory. From current directory, go inside the test directory. And what this means, again, the concept of the class path is Java looks for the type name, the name of the type. And you cannot give a full path to the class file. That doesn't work for Java application. Instead, you specify the directories that the JVM can look inside to finding a class file with this name with the parameter class path. And usually we have the dot. Dot means the current directory, which is this our Java native image, right? And then the class path separator is colon, always is colon, just like the path separator in macOS and Unix. So I'm specifying two directories on my class path when I launch this Java application. One is the current directory, the other one is the test directory, which is inside the current directory. So when I launch this command, JVM looks for a type called a class file called hello world inside the current directory. It doesn't find it, so it's from current directory it goes into the test directory. It finds that so that it is able to execute it. All right. Now let's add a little bit of complexity. What happens if we declare a package? We say that this class, this type belongs to a Java package. So package my package. All right. So you have to terminate with semicolon. What happens now? Obviously, we changed something in the source code, so we have to go ahead and compile it again, right? So right now I'm inside the Java native image, this source file inside the test. So I'm going to the Java compiler, go into the test, and then hello world.java, right? When you want to compile, obviously you have to specify the file, and it can be a relative path, absolute path, etc. So this works. If I open this class file again with the class file viewer, you see that the name of the type now changes. Look at the name of the type. It's the package dot the name of the class. All right. This means this hello world class or type is not a freestanding type. It has a fully qualified name. Now let's see what happens when we try to execute this. All right. Now, first of all, I'm going to go back to inside the test folder, right? So we have this hello world.class. If I say Java hello world, which we did before, so this command worked before declaring this class to belong to a package, but now this doesn't work. Could not find or load main class hello world, because now this class has a fully qualified name. So what we need to do, we need to specify the fully qualified name, and that's the package my package.hello world, and we don't use the dot class, right? So Java looks into the class path, which right now it's the current directory, tries to find a class file that has this name hello world, and it declares a type that has a fully qualified name my package.hello world, and then sees if it has a main method. If it does, it executes it, right? Now right now this didn't work. The question is why this didn't work. So let's see, Java -cp, we specify that dot, right? And then the question is, so the reason is that so my package dot hello world. Now the reason is that whenever you have a package, Java expects you to have a basically a directory hierarchy that corresponds to packages. So I'm going to create a directory, a folder called my package, right? And then what I'm going to do, I'm going to copy this inside this my package. And then and then what we're going to do, if I launch Java from the test directory, which is one level up from this my package directory, and then this works because whenever your class or type belongs to a package, it tells the JVM from the current working directory or from whatever directories that are in the class path, right? Right now it's the current directory, right? Class path dot. Dot means just a start from the current directory test. Whenever you have a fully qualified name, the way this is interpreted for the Java tool or JVM is that there is supposed to be a directory folder inside the current directory called my package, and then there's supposed to be a class file called hello world inside that directory, right? So if your class belongs to a package, then there should be a directory hierarchy corresponding to the packages on your hard disk, on your basically folders, right? So packages are a way of organizing them, organizing class files, but then there has to be a directory hierarchy that basically correspond to the packages. So you cannot just basically have packages without an actual directory hierarchy. And you can see that when your Java application becomes large, this kind of stuff, adding packages and creating these directories, becomes complicated. That's why we have IDs, and for programming languages like Java, you really have to use an ID because a lot of these complexities are automatically managed by an ID. Now, the last thing that I want to show in this example is that now I compiled my class. It belongs to a package, and it's correctly put in a directory that has the same name as package, which is correct. Everything's correct. But what happens if right now we saw that Java my package hello world works because I'm inside the test directory. What if I go inside another directory? So right now I'm in the Java native. How do I launch this hello world application which belongs to a package from another directory? So in order to do that, now I have to tell the JVM where the class path is. I have to, if I say Java my package hello world, it's not going to work because my current working directory doesn't have a directory called my package inside it, right? And if I tell Java and then from current directory go into the test and look for this is also not going to work. We said that when you launch a Java application using JVM, you cannot specify the path to the class file. That doesn't work. Instead, you have to specify the directory, which is in this case is test, right? As part of the class path. So we want to say dot from current directory go inside the test, which means search for a class file hello world, which is inside a directory my package, and that directory is inside one of the directories that are specified in the class path. Right now it's test, right? So this is going to work. Yes. So the name of your application is always the fully qualified name. You cannot specify a path to that class file. That never works for Java. Instead, you specify the directories that your application needs to launch, search for all class files using basically the class path. Now, the last example that I'm going to show you is, which also highlights the importance of class path, is I'm going to delete this. I'm going to delete this class file. Right now, I'm going to create another class folder called test2, right? And I am going to create a new and then I'm going to let's copy this Java hello world into here. Let's basically rename it. I'm going to call this car.java, right? And then let's open it. I'm going to define a class car. Remember, one of the rules is that if you have a public class in a source file, the name of that class has to match the name of the source file, right? And what I'm going to do here is that this car is going to have a field int, a price, for example, and I'm going to have a public constructor which takes the int, and then this dot price equals price. All right, and then I'm going to have a toString method. Let's see if this works. Source generate toString. Okay, so we cannot use those features. So public a string to a string, right? It doesn't take any parameters, and return car price equals basically percent %d for integers, and then dot formatted, and then price. And this dot formatted, I believe, was added from JDK 15, so I'm using JDK 17. That's totally fine. If not, you can use a string.format, which is a static method. All right, so back to hello world. In the main method, what I'm going to do, I am going to now create a car object, car new car, and pass a price 100, and then do a system dot out dot print line car. And we know that this actually calls the toString method. toString method on the car reference, right? Or a variable. Now let's see how complicated it is to actually get this application to run. Right now we have two directories, right? Test and test2. And these two directories have two source files, hello world and car. And these two source files define public classes, right? And we know that for the public class, the name of the class must match the name of the source file, which is correct. None of them belong to any class, any package, which means we don't really to put them in. When we compile to the class file, we don't need to put those class files into the directories that correspond to the names of the package. So these classes don't belong to any package for now. If they belong to a package, then we have to create directories that have the same names as packages, and then put the class files into those directories. But for now, for simplicity, I'm just going to basically not add this to any package. Now let's see how we're going to launch this. So first of all, I have to compile this source file. So I use the Java C, and note that right now I'm inside the Java native image directory. I'm going to go to the test and compile the hello world, and this doesn't work. Why? Because this hello world has a dependency on another type, and we know that each type, in this case car, compiles to a class file, and even at compile time the JVM needs to understand where this class file is, right? The Java compiler, not the JVM. So in this case, what we need to do, we need to basically compile the car class first, because it doesn't have any dependency. Java C test2 and then car.java, and this compiles fine. So we get this car doesn't have any dependency. So how do we compile this Java hello world that has a type dependency? So Java C, what we need to do, again, even for the Java compiler, it has to know where to find the types because of the type safety that the Java provides, which means even at compile time, all the types that you use have to be known to the compiler. Otherwise, there is no point of allowing the compilation. And again, you have to specify them on the class path. So on the class path, you tell it go into the test2, right? And then now this is the class path that the Java compiler can search for in order to see the dependencies of other classes. And then now I want to compile this hello world, so I tell it go to inside the test and then hello world.java. And now this works, because when the Java compiler goes to compile this file, which we give it as an either absolute path or relative path, doesn't matter, it needs to first understand what this car type is. And because this car type doesn't belong to any package, so we don't have an import statement. But then in order for it to understand it, Java compiler needs to first know whether there is a file called car.class. So Java compiler, when it tries to compile this hello world Java, it first needs to make sure that a class file called car.class exists on your hard disk, which means now you have to go ahead and compile that car.java first to create a car.class. And then the next step is that for the Java compiler, if the car.class file exists, you have to tell the Java compiler directories that the Java compiler can search into them to make sure that that car.class exists, right? In order to do that, again, you have to specify those directories using the class path, right? So we tell the Java compiler, compile this hello world.java file, but if it has dependencies, search for dependencies inside this directory, test2, all right? We could do, for example, test2 and then, for example, test, actually the class path separator is colon test, right? We could also do that. That still works fine. There is no dependency that the Java compiler needs, which is inside the test. So we were able to successfully compile our source files, which were physically in separate or different directories on our hard disk. But because they don't belong to a package, you can compile them directly, right? Now, if I go inside this test directory, right? That's where my hello world.class is. You can definitely guess that if I try to execute it, note that it doesn't belong to any package. So just you specify the name of the class. It's not going to work. It actually works up until hitting this line car, right? Because these two lines execute because they don't have any dependency. They only depend on the JDK classes that JVM already knows. The Java command already knows where to load them. But then it says there is an exception in the make no class def found error, which says I couldn't find a class file called car.class because you're trying to use the new operator to create an object of type car. But JVM says I need to first understand what this car is. And the way JVM understands that, it looks for a class file, a file called car.class. It couldn't find it. So what we need to do, we need to specify another directory that has this car.class, and you can guess that we do it with the with the class path or -cp parameter, and we say that from current directory, which is in the test, go one level up, go to the Java native image, go to inside the test2, right? That's where you find this car.class. And now we're going to launch our application, the class file. Could not find or load the hello world. Why? Because when you specify the class path, right now I'm launching this hello world. Even for the hello world, Java searches inside the class path directory. So you should always add the current directory if your class is inside the current directory. So dot colon, which means current directory, which has my class file, and another directory which goes two level up with respect to the current directory, and then goes inside test2. All right, and we shouldn't have any spaces. So right now there are two directories that are on my class path. One is the current directory. Why? Because my hello world class, which is the entry point to my application, which has the main method, is inside the current directory, this test directory. That's why I specify dot. But then this hello world class has a dependency on the car, and the car class file, car.class, is inside the test2 directory, and I specify a relative path from the current directory from the this test, which means go one level up and then go inside the test2 directory. And now my application works fine, because at launch time JVM can find a class file called hello world.class. It has a main method, it executes that, and inside that there is another type car. So JVM can also find a file called the car.class. So it can also understand what the car type is. All right. So I hope you really enjoyed this lecture. My goal was to really go into depth of what's going on, and in the next lectures, when we compile this Java application to native executable binary, you see that there is no concept called class path. And executing native binaries are easier in terms of you don't need to deal with kind of class path stuff, right? So please stay tuned, and I'll see you in the next one.